Hello.
Hey, good morning.
Hi, good morning.
Uh, just the two of us right now, but just give it a little bit more time.
Yeah, sure. Is it which are you in the PT in the PT the time
Yeah,
zone? 8
yes.
o'clock. So
I'm
so
in
it,
I'm in California.
okay,
Yeah.
nice.
Where are you located?
So I'm in Athens, Greece.
Oh,
So it's EET.
okay, cool. Oh, we got
It's
Fabiano here. That's awesome.
Hey Fabiano.
Hey folks, it seems that audio is getting from a lot of places, but not my headphone. So yeah, now I can, it's okay. Hey Rico, long time no see, Rico.
Yeah, long time no see. Good to see you.
Tell me you be in London, man.
I'm not really sure yet. I might. Are you going to be there?
I'm going to be there. So
Oh, I hope to go and I hope to see you there. If
yeah, you have my contact, man. Just drop me a message if you happen to be there. Like it's been a long time we don't meet face to face.
Yeah, no, I think last time we saw each other was in Amsterdam.
Yeah, exactly.
So it's been a while. Um, so I posted the meeting notes on the chat. So please add yourself as an attendee. Okay, I think we could get started. Well, welcome everyone to the TAG-Runtime Meeting, Thursday, February 20th. And happy to have you here. And today we have Anastasius. Did I pronounce your name correctly?
Yeah, it's fine. Yeah.
Anastasius, and you're going to be presenting about urunc or microrunc.
Yeah, could be microruns.
Yeah,
Uh,
so
so we are going to do a joint presentation with my colleague Babis Karalabos.
okay.
So we're both Greek. Sorry about the tough name pronunciation. Um, so we can see Fabiano as well.
Yeah.
So yeah, we're going to talk about a container runtime that we have been building. Um, essentially it's we aspire to have the runc of Unikernels. So we want to run Unikernels in a cloud native way. We try to do that. There were some projects in the past we had to rewrite and do a bunch of hacks. So we decided to do that on our own. So we came up with urunc. I'll let Babis go into the gory details. We have a couple of demos planned. But yeah, let's get started with the slides, and we can go over the demos.
Good.
afterwards.
Okay, so hello from my side too. I hope you can see my screen.
Yep.
Yep.
You can also see it right now.
Yep.
Okay, great. So, I guess everyone here is familiar with the magic that containers brought to us. It's quite very easy nowadays to simply package our application with all the necessary files. This could be configuration files, any kind of runtimes that, for example, any language runtimes that we might need, any external libraries like SSL or any other kind of libraries that our application requires. We can package all these things together in a single bundle, and we can deploy this bundle either in the cloud or execute it in almost every computer that we have, with solving the problem that it doesn't work in my computer, but it works. It works in my computer, it doesn't work on your computer, and stuff like that. And we know that also containers have created this kind of, have been the driving force of the cloud native ecosystem. We see so many projects around containers. It's really a rich ecosystem with so many diverse tools, so many options of creating, managing, deploying containers. It has been quite a lot of work and effort in this kind of aspect. And that makes sense since containers are quite the de facto application packaging and deployment mechanism that we have nowadays. They are very lightweight, they can spawn very fast, and as we saw, they're very portable. And of course, all this ecosystem really makes containers very adaptable for a lot of use cases. However, as we all know, containers get some of their benefits from one thing, that they share the kernel underneath. So what happens is that we have a container running alongside other containers, and they share some components that they come in the system, like and more specifically the kernel. And this is not great for cases where we have multi-tenancy, especially, for example, public clouds. Because if something goes wrong, and we have a malicious container and it manages to leverage and escape the container runtime, the isolation that we have from the container runtime, then the kernel is exposed, or other container runtimes are exposed, and this is really not good. And to tackle this, we have created sandbox containers. So sandbox containers is just we can think about it of just adding another isolation layer to have, let's say, isolation in depth. And what happens is that we have another layer which communicates with the container and acts as a mediator between the container and the host kernel. And hence we protect the host and other containers from any malicious or untrusted user and container that we might have. So this sandboxing can come in different forms. It can come in the form of software, like, for example, Gvisor is a very popular project that does it, and also in the form of virtual machines, where we leverage hardware-assisted virtualization, and we create this kind of sandbox through virtual machines. And now here we have a lot of options, so we can have a pool of VMs just waiting to, where we can simply deploy containers on them, acting like, for example, as Kubernetes nodes, or we can have container runtimes like Kata containers that take the burden away, and they can easily deploy containers on top of the VMs, and they can also manage a VM for us. So we don't have to do anything, and the container is automatically will be deployed, will be executed inside a newly spawned virtual machine. But looking on this kind of stack, we see that we have this kind of architecture where we have a container running inside the VM, that this VM has a rootfs, it has its own operating system, its own kernel, running on top of a virtual machine, which runs usually as a process inside another operating system. And we see a lot of redundancy, a lot of things that are quite a lot of layers that are quite maybe redundant in some cases. Because if we think about it in more application specific, and what an application really needs to execute, it's not the whole stack. It just needs some components of the runtime, of the language runtime, some components of the libraries, and some components of the guest kernel to execute. And if the application has all these parts, it can easily execute. And that's exactly what Unikernels can do. Unikernels can take one application and they can package everything that this and only this application requires in order to execute properly. This can be the language runtime, the libraries that the runtime and the application require, external libraries, for example, the SSL as mentioned before, or even, and of course, let's say the kernel libraries. To make it a bit more clear of what exactly unikernels can do, unikernels are usually specialized machine images, but in our case, since we are mostly referring to the cloud, we mostly refer to virtual machine images. They have a single address space architecture, which means that we don't have a separation between the guest and between the user space and the kernel space, and they are usually constructed from library operating systems. So library operating system is a concept of operating systems that allows every component of the operating system to act as a library. So when we construct this kind of virtual machines, this kind of images, we can cherry pick only the necessary components, only the necessary libraries that our application requires. And the benefits of such an architecture is that we have extremely faster boot times compared to traditional VMs. We have a much smaller memory and disk footprint. It can be even in the size of kilobytes. They have a very reduced attack surface because it's a much smaller scale image, and they are truly isolated because they're running on top of a VM. Like they inherit this kind of isolation. Now, despite of all these kind of great features that unikernels come with, we see that it's not really easily adaptable in the cloud right now. And we identify mostly two reasons for that. First of all is packaging. As I mentioned before, unikernels are virtual machine images. So it's not that we cannot just deploy them easily. We have to package them and look and distribute them. And the best way to do that right now is using the OCI, which is the de facto packaging and distribution format that we have for cloud native applications. So in that way, we can easily package them. That's not a problem. But the problem is that we don't know how to manage them and how to execute them. And that's because unikernels are not like containers. It's not just a normal application that we can just execute over any operating system. And in the same way, they are not like traditional VMs that they are not that feature rich, and they cannot be deployed and be, for example, sometimes even long running. In some use cases, that's not the case. So we focus on the deployment, and we came up, as Tasso said in the beginning, we came up with urunc. So urunc aims to be the runc of unikernels and similar technologies. It's a CRI compatible runtime. It's written in Go from scratch, and yeah, the goal here is to allow to create and to be very extensible and add and create an easy way to add support for more guest kernels and for more hypervisors without any modifications, both in the guest kernels and in the hypervisor. And the key difference between other sandboxing, for example, container runtimes that exist, is that we spawn the application directly inside the virtual machine, and we treat the VM as a process that we have to handle as a container. And therefore, we have one VM per container and not one VM where we spawn a lot of one VM that we spawn the container inside. To make the distinction a bit more clear, on the left of your screen, we have let's say for example, the normal architecture that we have with VMs that we spawn containers inside the VMs. And on the right, we have the architecture of urunc, that we have the container, that we have the VM that is running inside. We have the VM that is running inside the container, or the unikernel that is running inside the container. And that allows us to have some kind of, for example, why we do this is because we, in that way, we don't have to change anything in the unikernel. We can just run it as a process, and we treat it as a process. And on the same time, we think that it's much easier to have one layer that we can easily focus on that. And since we are the people who manage this layer here, we can easily identify which components that we have to isolate and how we can really restrict this process and run here almost anything without a lot of worry. And yeah, in a different visual view of what exactly urunc is compared to other container runtimes, we have runc, where the application is running inside a container that is usually using kernel features like namespaces, C groups, capabilities, and stuff like that to create this kind of isolation boundary. Then we have the case of kata containers, which do the same thing, but they do it inside the VM. And we have a VM that is spawned before the creation of the container. And then we also have the case of urunc that does quite the opposite. We first create a container, and then we spawn the VM inside the container. So to give you in order to integrate urunc with Kubernetes, we have taken the approach that I said before, that we have one container per VM. So every other kind of containers, like sidecar containers and stuff like that, they're running on their as normal containers that can be deployed over traditional container runtimes like runc. And in that way, and the reason that we choose to do that is because the sidecar containers, in most cases, are containers that we trust. For example, you can think about for Knative, right, where we have the kubeproxy. This container is part of the system stack, so we don't really need to isolate this container, and we don't need to run it inside the VM that is running the untrusted code. We can just have it running. We can just run it on the pod, and then we can simply isolate only the untrusted part of the code that we have in our system. And yeah, so in order to make this work, we use TC mirrors between the VS and the tap device. And yeah, we actually quite cheating here because we just copied that from kata containers. So we have this kind of tap interface that is attached with the virtual machine, and it can communicate with the outside world through the tap device that is mirrored with the Ethernet endpoint. So we can do some demos now. If we can, for example, show you how we can simply build container images and run them with urunc. So let me share. Okay, I will share my whole screen. That's going to be easier.
And of course, guys, if you have any questions, please feel free to.
Oh yeah, feel free to interrupt us. And
how is the questions compared to Unicraft? Unicraft is more like tooling for unikernels, or this is more like the runtime?
Exactly, yes.
Okay. Does it
So,
sorry, go ahead.
Yeah. So I think the demo will answer your question, because so for example, we will go here to this directory. So here we have the HTTP server that we took from Unicraft. Yeah, so this is the one of the examples that Unicraft has. It's a simple C application. It just acts as an HTTP server. So we will follow the, we're not going to use CraftKit, but so we will just build it as a Py executable. And so we have also created this kind of, so we also have created Bunny. Bunny is a separate project that aims to allow us to create unikernels easier. And currently it doesn't really build unikernels. It builds WASM unikernels, but this is quite experimental right now. It is right now it's only able to package unikernels associate images that can be deployed with urunc, and it acts as a build kit frontend. So we can it has very easy integration with Docker. So to give you an overview, here we define which platform, which unikernel framework we're going to use. In this case would be Unicraft, the version, the monitor that we want to execute it on top of it, the architecture, the rootfs. Here we define that we want to build it from scratch, and we want to include the file that we just built it. And of course, the kernel, we will use the kernel that Unicraft has. Unicraft has done quite a very beautiful work with their catalog, and they have already some OCI images with, for example, Unicraft base is a base image of Unicraft that can run this kind of Py executables. And here we just define the path inside the image that we're going to use in order to specify the kernel that we want to execute. And of course, here we have the CMD line. So what we're going to do is just to, I think I have it already. Yeah, so we're going to just do, let's call it CHCP over FC. Oh, so this one will just build here. A lot of things are already cast, but what it actually does is that it creates the initRD that we will give in Unicraft. And we already have the kernel from Unicraft. And we can just do a Docker run. And the only thing that we have to do is just specify a different runtime. In our case, it will be urunc. And we can use this here, and that's running on top of Firecracker. So if I do, yeah, that's not. So if I, oh, okay, sorry for that. Yeah, so we have some other things running right now. That's from Kata though, but here is the actual thing that we just spawned now. And if we do an inspect, if we check, we will see here that we have the our unikernel running as a container. And we can do an inspect to get the IP. So this is IP, and we can do a curl here. Yeah. Maybe I need to do this. Okay, and here we have the byword. The byword was, yeah, this is still running. We can stop it though. So if we go here, so we have this message that we just printed with the byword, and we can change this message, and we can rebuild, and we can have the whole unikernel again running. We can do it right now, but maybe it would be more. It would be quite. Oh, actually, I can show you. I have here one more example to show the. Yeah. So this is the Nginx example that Unicraft has. So here, because we don't change anything in the rootfs, we can simply pick the OCI image from Unicraft. and we just define the command line that we want to execute. And yeah, if I do a Docker build again, and I call this nginx, was it over Firecracker? Or okay, over CAM. So now we selected Camel. So the bunny will, depending on which platform we select, it will fetch the respective events from Unicraft. And we can do a run again. Okay, so here you can see that we are running over Camel. And if I do again, yeah, so if I do an inspect here to get the IP, okay, so I have the same. And yeah, here we have the hello from Unicraft message from the nginx running on top of Unicraft. And we can stop this one. So I think maybe it's Tassos, would you like to continue with the demo with Kubernetes?
Sure, but before that, Victor had a question in the chat. I'm not sure if you saw about the image size.
Okay, yeah. Yes, that's quite a good question. So currently, because we're using the base image of Unicraft, this is quite big. It's around, if I remember correctly, around 18 or 20 megabytes or something like that. But like if we use another kind of Unikernels like Mirage or even Unicraft, if we use a more native execution in Unicraft, we can have extremely smaller image size. We had in FOSDEM, in the presentation that we did in FOSDEM, we did this kind of experiment and we measured different kind of images that we had with Unicraft, Linux, the Kata Linux kernel. And yeah, I don't have the slide right now, but like
you can show using the Docker image ls command. I think you can show an indicative.
Okay, yeah. So this is the one that we created with. Yeah, it's around 2 megabytes. The image that we have from Docker.
Should be compressed.
And
I think this is the compressed.
Compressed. Yeah.
Yeah, and maybe some shared layers. I had one more question about the platforms. So there are, it looks like there are multiple unikernel platforms, and then there are sort of hypervisors you're running on. I've seen QEMU and Firecracker. I assume Intel's hypervisor, I forget what it's called, might be supported as well. But how many frameworks are there?
That's another question. So in the good old days, it used to be every framework for every different language that existed out there. But quite a lot of projects go up and go down. So maybe I can switch to the slides. Yeah, so currently there are this, for example, Unicraft is maybe the most popular framework that exists. It has a POSIX-like environment. So all the ones that you see here on the left, they provide the POSIX experience. Also, this is Rambran, which is based on NetBSD, and this is OSV, which is also quite popular unikernel framework. But we also have, let's say, the more clean state unikernels frameworks like Mirage OS, which is entirely written in OCaml. We have Muse, which is one that is tailored to run WebAssembly. And then we have Rusty Hermit, which is which is written in Rust, but it also has Linux binary compatibility. So yeah, there are quite a lot of frameworks, and the idea of urunc is to allow all this kind of small and similar kind of technologies to create a platform for them that they can be easily deployed.
Thanks.
Also, there is include.s, which is written in C++. It's yet another, let's say, clean state unikernel that it doesn't have, let's say, POSIX compliance. It doesn't comply entirely to POSIX.
Babis, sorry, Victor, just to build like on Victor's question. Victor also mentioned like about like what is the work that is needed to have other hypervisors running, right? Like cloud hypervisor, for instance, that was part of the question. So if you need to get that done, like what is the work that should be done if someone gets interested to do such integration?
With urunc, you mean, right?
Exactly, to use like the cloud hypervisor as VMM, for instance, for.
Yes, so we kind of have an interface right now in Go. So the only thing that is currently required is that you just need to simply implement this interface. And this interface just has, maybe I can just show it in the repo. So if I go here, so here I think is a definition. So these are the things that we have to implement for the NVMM to be supported. So if I go, for example, in Firecracker that we have here, you can see that it's quite, yeah, like, okay, Firecracker is quite a special case because it has it doesn't get command line arguments and stuff. So we need the, in the current case, we just spawn it over a config file. So we just generate the JSON file and then we just spawn the process. That's actually what we have to do. It's quite easy, very straightforward.
Yeah, I can see that would be like more or less the same for any kind of RSVMM based one. Yeah. Yeah, thanks. Victor, back to you.
Yeah. Similar, I guess, related question. If the tooling isn't handling the build and you're sort of providing the initial RAM disk and VM image, what is the platform option giving you? Are y'all packaging versions of like I'm not sure what you'd get from like what would you get from specifying Unicraft, right? Like it's clear what you get from specifying QEMU versus Firecracker. It's not clear what changes between Unicraft or let's say rump, etc. as far as running it.
Yeah, so the difference is that every kind of unikernel has its own way to pass, let's say, kernel boot parameters. So this is the differences between the unikernels are quite extreme, not only on the building but also on how you can run them. So yes, we can have quite a lot of monitors like Firecracker, QEMU, and these are very well established and easy to execute them. But every guest has its own way, first of all, to get parameters, and secondly, they have different ways of storage. So Unicraft, for example, gets rootfs from initrd. Other kind of unikernels like Rampran or Mirage.os, they get it from block, from Virtio block. Unicraft, as far as we know right now, we are not very aware of it, but we haven't managed to run it over Virtio block. And there are other kind of cases like, of course, Linux that has support for everything. And there are other kind of cases like include.os and other kind of unikernels that they have a different kind of, let's say, more like an in-memory FS again, but not exactly in initrd. So the reason that we have, especially here in Bunny, the framework, it's to allow us to, depending on the framework, we have to build the rootfs in a different way. So either it has to be a block device, either it has to be an initrd, either it has to be some kind of form of a different file. that is supported from the respective framework. And of course, in the case of urunc, we need to pass the respective command line arguments in order to allow that to run it, and the Unikernel to understand the file system and everything.
Thank you. That's a great answer. I understand now.
Babis, I have another question if you don't mind.
Mhm.
I'm just thinking here, like everything that you showed us, like you were building locally and then like you were running from your local built image, right? I'm quite interested like on this getting to the OCI registries and how this can be shared by, like by and for anyone else, because inside Intel, for instance, we are very used to libOS because of graphene, like whatever. Well, the name like that will tell your age, but yeah, let's say Gramin, because I want to just like look younger. And one of the problems that we have is like we miss some kind of OCI registry where all the images are compatible that people can just go there, grab it, and use it. So if you can show me one example of that, that would be amazing if you have it prepared.
Yeah, we currently we just have we just bundle the kernel inside the OCI image. So we just copy the kernel inside the OCI image, and we just let's say deploy it. We just store it over Harbor or anywhere, just a typical OCI image. And we use annotations for urunc in order to inside urunc in order to understand what kind of kernel we have, which kind of monitor we want to execute, which kind of. So maybe I can. I'm not sure if. But I can go here to urunc. I can go to the documentation that we have to explain that. So. Where do we have it? Here.
Just a small comment, Bobby. So, Fabiano, this is one of the biggest pain points we had with implementing proper support, because for some reason the image annotations are not propagated correctly to the runtime. So we're not getting in urunc. We're not getting the image annotations we add either as labels or as OCI annotations during the build. So we have no way of knowing what kind of platform or hypervisor or unikernel we're going to run unless we add this file that Babis is going to show.
Yeah, so to build on of what Tassos just said is actually we have this issue with containerd. When we run it with Podman, everything is okay for some reason. So maybe something we miss with containerd, and we don't get this kind of annotations. These annotations are stored in the image manifest. And usually what happens is that we just specify here, for example, the unikernel type, which is the framework that we saw earlier, the hypervisor, the kernel, the CMD line, and the init.rt and other kind of things. But to overcome this kind of problem, we have created a JSON file that we store inside the container.fs, and we simply just have this kind of annotations written directly to the JSON file. So this is our approach. We don't believe this is the optimal approach, to be honest, but it's quite an implementation detail, I would say. It's not that it's not that critical.
It makes sense. I think that Podman passes like the whole OCI image like is packed down, which containerd is not doing. Containerd is just like filtering what you end up like receiving in the container runtime side. So yeah, it makes sense, and it's nice to know that this is also running on Podman.
Yeah, and
sorry. And another thing is that one of the reasons that our guess is that one of the reasons that Unicraft is using their own toolkit. It's their own toolkit and runtime and custom runtime, and it's not CRI. It doesn't seem that it is CRI compatible. Is that containerd cannot fetch a different platform? So if you specify platform, a different platform and OS, You cannot store it in the Docker Hub, let's say, and containerd would have trouble fetching it if it's not running on the same platform. So you cannot run a Unicraft unikernel on a Linux platform, although you could. We saw that or something like that in a different project that we're working on, where we annotate these images, where we use OCI images just to store data blobs with custom OS and platform annotations.
Yeah, so Unicraft, which in my opinion sounds very reasonable. They have gone to the OCI images the spec, and they have simply defined that. Okay, so I defined that OS for me. I know that I am Unicraft. I will only run Unicraft, so it's easier for them. But the thing is that in order to distinguish between Firecracker and Gemu, they use what Tasso said, that they change the OS name of the image. So in the OCI image, in the platform section of the OS, they specify there the hypervisor. So they specify Gemu or Firecracker, and you cannot pull it directly, because if you do a Docker pull in this kind of thing, you have to specify the platform Gemu AMD64 or ART64 in order to fetch the image. Otherwise, you will not be able to do that, because by default you use the host system, right? So you're gonna try to fetch a Linux image, and it doesn't exist. This could be also an approach that we could use. But we have to see how we can integrate that with containerd. We have to get a bit more familiar with the different platforms in containerd and stuff like that. It can be something that we can definitely look in the future.
I see. Great answer, man. Thanks.
So, Tassos, would you like to show the Kubernetes demo?
Sure. Yeah, so you have to stop sharing.
One question,
okay.
for the community, the users, do you currently have folks using this in the community?
So at the moment, there are people that are experimenting with urunc. So it seems that there is a need for people to to be able to run unikernels in Kubernetes, in pure Kubernetes, in a generic Kubernetes environment. So we have seen a couple of issues on GitHub about trying to run Mirage or trying to run on EKS, trying to run on a managed Kubernetes environment on premises with various CNIs, stuff like that. We've seen that people are engaging with this idea. The thing is that without having this tool that Bobby shared, that you could easily build a unikernel, it's kind of hard. So at the moment we leech on on the Unicraft catalog, so we can this was one of the issues that people fired up on GitHub. So how can I use the Unicraft catalog unikernel to spawn a unikernel on urunc? So we kind of caught up on this and implemented a way to fetch an image, create a urunc compatible, an OCI compatible image, and spawn it as a unikernel. So, and it's one of the reasons that we would like to be included in the CNCF sandbox to get more reach, to see to be able to get exposure, let's say.
Makes sense. Yeah.
Yeah, and actually, Bunny, the thing, the small front end that you saw earlier. So the idea there is to have it in the future. It will be able to build a unikernel for you. So I can maybe later show you a demo with Wasm, because it is able right now to build, for example, a Rust HTTP server over Wasm, and it can run it. Not run it, it can build it as a unikernel. So this is the idea is that you have a small YAML file, you just provide the source code like in Docker, like normal container, You define how your application is built, and Bunny will do that all by itself. So in order to allow the people to easier create these unikernels, because we understand that it's not that easy to fetch a toolchain and do all these kind of things without any experience on that.
Another question is the device support is there for most devices, networking, CPU, GPU, and maybe like an external high performance type of things. So is there any interest for that or not yet?
So that's
Sorry,
what you can go.
let me take that. So there is interest from the academic community first about hardware acceleration unikernels, mainly the telco people. So people have when we present that in the academic context, people are saying we used to use unikernels, but there was no hardware acceleration support, so we did that. Regarding this specific thing, we have another project that we work on, and it's about API remoting to use hardware acceleration. So we have a couple of integration points with Unicraft, and I think we do have a ramp demo.
Yes, we do.
But it's quite dated. So we're using this framework. We call this framework VXL. Using this framework over VirtIO semantics, we're able to abstract semantically abstract hardware acceleration functionality. Let's say image inference, or I don't know, a TensorFlow session run, or Torch JIT forward, stuff like that, like high level functionality that is later backed. Later in the stack, I mean, backed by hardware specific plugin. So you can implement that using a GPU implementation, or a CPU, or a TPU, or whatever. Regarding networking or custom networking stuff, we haven't experimented in this iteration. It depends on the actual Unikernel framework. I mean, if you want to pass through a virtual function from a high performance network device, you need to have the driver inside the Unikernel, which is kind of tricky, I would say. I'm not sure these frameworks are there yet.
Yeah, makes sense. Yeah.
So if I have
like InfiniBand, for example, like support for
so imagine if you have to port the verbs API to Unicode. Let's say that's going to be a mess. If I have a bit of time, I would like to show you.
Yeah, that'd be great. So sorry, I think Victor had another question. Did you have another question?
Oh, no, sorry. I just did a little Googling around that, the annotation pass down issue, since that sounded like something Containerd should definitely allow. But
yeah,
not sure.
I think we need to reiterate with Containerd. I mean, we have asked in the past. It's something that we're missing. It's definitely something that we're missing. So maybe we need to sit down with Containerd and with the people involved in Containerd and discuss that, understand that, and maybe propose something that would facilitate the annotation passing, because it's kind of frustrating having to do this JSON.
I can tell you, like, there was a lot of changes on Containerd when it comes from 1.7 to 2.0 regarding the image pooling, the architectures as well. So take a look on the newest version of Containerd, because that may, at least, like, you can start experimenting from a better place than it was in 1.7 or older versions, because there were like a lot of changes on that front.
Okay, we will. So we have here this script that creates a cluster in AWS, a managed Kubernetes cluster. So the rationale of this demo is to show how easy it is to install urunc on Kubernetes nodes. So we have the script, we create the cluster using the CloudFormation thing. We unfortunately we don't get support the AWS CNI. We can go into the gory details if you're interested. So we add Calico, we add the Calico installation, we create a node group with one ARM64 and one x86 machine, recent Ubuntu, and we enable SSH access to the nodes, just for debugging. So I have run this script here because it takes a lot of time, and we wouldn't have the time. I run the script here, so this is a fresh cluster. I wanted to show that it's as easy as running the kata deploy thing. So I just executed kata deploy. Let me just get the state of the cluster. So we've got the CNI, we've got 2 kata pods, we've got the kata deploy and Calico. So if I go to the YAML file that I will deploy, it's essentially a copy from copy. It's essentially the logic of kata deploy.
Aha. Sorry, go ahead.
Of course. And we have a container image. We have all the artifacts that we are interested in. So we've got, we ship generic hypervisors here. We have a volume mount to touch the configs. We also have support for K3s. So we have the overlay just as kata does. So we apply the RBAC thing. We apply the deploy thing, and we get this is hosted on our own cluster. So upload is going to take, it's not a lot, it's 100 megs, but upload is limited to 20 megabits per second, so it's going to take a bit of time. Until then, let me show you what I'm going to deploy. So this is a simple Nginx built on top of Rampran, running on top of Solo 5. And it's the manifest is only for x86, so it's only going to run on an x86 machine. This is an HTTP reply, a simple echo thing that we have been using for Knative. Running on top of KMO, this is Unicraft. We specify the runtime class, and this is a multi-architecture manifest. So it's going to be running on x86 and ARM64, and the same stands for, this is exactly the same, only it has a Firecracker backend. Let me check if the deploy is finished. So one of the two has finished. Check the logs. So we've got everything went well, which is good. And should be the same here. Yep. So if I go and apply, I should do the runtime class first. And if I go and apply the examples, so I get container creating, I get the ones that are multi-architecture are being spawned in both nodes. The one that's x86 only, it's being spawned on the same node. So let me get the IP addresses and let me go. Let me run a helper pod. Okay, so I'll start interacting with, this is the ramp-run Unikernel. I can see the HTML being served. This is the HTTP reply QEMU, so it listens on a different port, it serves another HTML. And this is the Firecracker one. Again, we could log in to the nodes, like to see. Name. Okay, so this is the x86 machine. So we've got two Firecracker VMs. We should have, this is the Kata QEMU. This is the urunc QEMU. And we should see a Solo 5 as well for the Nginx. And I think can delete that. Presumably, yeah, everything is deleted here. So these are the two Kata pods. So we have put a lot of effort in having it multi-architecture, in making it easy for someone to try it out in a managed Kubernetes environment. Feel free to ask any questions.
It's great. We got a couple of minutes, but looking forward to seeing this in Sandbox and the CNCF and continue to evolve and grow.
Okay, that's good. That's good to hear. Any advice regarding the Sandbox application or something that you would like to see there?
I think you should be okay. Sandbox is not very strict, so the bar is not super high. I would highlight, the relationship with the cloud native ecosystem, right? So like with Kubernetes and containers. So I think generally, I think you're pretty good. I think Unicraft is already Sandbox, so yeah.
They're not. No, they are under the Linux Foundation, I think.
Yeah,
Due to the Zen relationship, I think they were there and not CNCF.
not in CNCF, yeah. But yeah, I mean, yeah, if you have the Kubernetes integration, and you also run with things like runc or run with containerd, and so those are all projects in the ecosystem in the CNCF. So
Yeah,
seems
we have
you
a couple of
can
demos.
highlight those things. Yeah.
We also have a couple of demos with Knative, so we can spawn
Yeah.
functions as Unikernels with Karmada, with the multi clustering.
And man, like one thing that I would like to recommend is make sure that you have the image story covered as well, right? Because that's like distributing as an OCI image, making this easier for others to consume. is where I saw the highest barrier for other projects to actually get adopted. And you guys are doing like a very nice work on trying to solve this in a way that seems like very, very nice. So please highlight that as part of the application as well, because people will be looking forward to that. And thanks a lot for the presentation.
Thanks, guys. Thanks so much for the feedback and for the pointers.
Yep. Thank you very much. And also feel free to ping any one of us on the Slack channel. So if you have any questions about the sandbox or any other questions. Sounds good.
Thanks. Thanks so
Bye.
much.
Bye for now.
Thank you. Bye-bye.
Bye.